Welcome back, folks. Still looking at this shortcut, still moving through these as quick as we can. We looked at another problem that had a supernode, and it looked like this. Okay, maybe it was a little more over that way. Anyhow, so this was one that I tried to trick you. Maybe I did, maybe I didn't. Maybe you've fallen asleep and you're just stuck on autoplay. Okay, but I tried to trick you. This is a node in here, so it ends up being a 4x4 just like the other one. Maybe I'll make this one a little bigger. But we also end up with a supernode here. Okay, same kind of situation. Thought about leaving it out from the shortcut. Thought about leaving it out from the original, but you know, if I did it in one place, I think it's worth going back and doing it with the other method, the shortcut method that we're learning right now. Okay, so it's going to be 4x4. We're going to write a KVL for the supernode. We're going to write a KCL for the supernode. Maybe I won't draw the matrix right-hand side yet until I fill everything out. And I write a KCL for A and a KCL for D. Okay. Let's get at it. KVL for the supernode. So we've got A is not connected to it, B is on the positive side, C is on the negative side, D is not connected to it. I drew the bottom. I hope that works out for me. Writing the KCL for the supernode. Oh, and I said I wasn't going to... Well, you know what? I made some decisions there, and we're going to stick with them. Okay, we survived the last one. Hopefully we survive this one too. Right-hand side of that KVL for the supernode is 8. Okay, what is A connected to that's also connected to B? And I see the 6 ohm. What is connected to B? And since it's part of the supernode, it's going to be positive. So I'm going to get 1/6 and 1/12. Okay. What is C connected to that's also part of the supernode? So it's positive. I'm going to get 1/8 because it's only this one this time. And then what is connected to the supernode that's also connected to D? And I see this 8 here, so it's negative 1/8. Okay, no current supplies on that one. Right-hand side is 0. Woohoo! Okay, now these two. They're the ones that should feel familiar by this point. Okay, so what is connected to A? And we're writing the equation for A, so it's 1/3 and 1/6, also known as 1/2. Okay, what's connected to A that's also connected to B? I see the 1/6. Okay, what's connected to A that's also connected to C? 0. What's connected to A that's also connected to D? 0. No current supply, 0 on the right-hand side. Okay. Coming down here, so we're moving over to this node. What's connected to D that's also connected to A? Nothing. What's connected to D that's also connected to B? Nothing. What's connected to D that's also connected to C? It looks like the 8 ohm again, negative 1/8. And then what's connected to D? I see 1/8 and 1/5. Boop, boop, boop. No current supply is connected to that node, so 0 on the right-hand side. Okay, solving that. We're going to find VA, VB, VC, and VD. Okay. And we get something that looks like that. And let's see what that looks like. 0, 1, negative 1, 0, and 8. Negative 1/6. Positive 1/6 and positive 1/12. 8 inverted, negative 8 inverted, and 0. That's 0.5, negative 6 inverted, 0, 0, 0. Oh, these get a little faster. 0, 0, negative 8 inverted, 8 inverted plus 5 inverted, and 0. And we get, man, I hope I'm right. These don't look as familiar to me, but you know, my mind's kind of awash in all of these numbers, so could happen. Let's go with it. 755.9 milliamps, 2.27 amps. Amps? Volts. Volts. Think about your units. 755.9 millivolts. 2.27 volts. Always stop and think about your units. Okay? I might have just prevented a plane from crashing there, or a submarine from blowing up, or something like that. Okay? Think about your units. 2.20 volts. Negative 2.20 volts. Okay. Those don't feel as familiar, but maybe I'm right. I'm brave. Let's see what's going on here. From the previous video, let's see what we found the last time we did this. From previous video. And let me go get that over here. Oh, yep. Oh, it was split between two rows. Sloppy, sloppy. But let's see what that looks like. Come here. Oh, it's tiny. Look how small it is. Let me zoom in a little bit. Get you some more pixels, free of charge. Okay. So that was from the previous problem. Let me just get a bigger eraser here so I can clean this up quick. Okay, we clean that up. We're not looking at V out right now. We're just kind of trying to make sure we get the right nodes. So check these matrices. You're going to find that they're equivalent. They might be a little out of order, but the solution ends up being the same. 755.9 mils, 2.27. Ooh, I rounded a little more this time. Sorry. Negative 2.2 volts. Okay, we can see that that's identical down here. Shortcut works. We can do it with a super node. So hopefully you're feeling less intimidated by it, and that you're also realizing that you can do these fairly quickly and accurately, because both are important. Okay, I think I'm going to skip over dependent supplies. Same problem with dependent supplies. You can do it if you're really clever. I'm not really clever, so I usually skip using the shortcut on problems with dependent supplies. Okay, so I don't know. Let me think about that one. Maybe you'll get a video, maybe you won't. Stay tuned. Good luck.